Hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Today's discussion, I'm going to look at the concept of the standard deviation, and this is going to be one of the treatments of data which is going to assist us restore the specific units of measurements which have been used, especially in trying to do a treatment of data. Now, this is going to be borrowing from our previous discussion. We have looked at the concept of population and sample variance, and we have decided that basically we can represent the population and the sample variance using a specific formula, and of course we are going to have these ones given as such, and as decided that basically it's going to be given in terms of this particular symbol representing the population variance, and then we shall have this specific symbol representing the sample variance given as such. So we have taken a consideration for the raw data and the frequency distribution for these two particular cases. We are by mentioned basically that for us to have this concept of a sample or a population variance, we are going to consider the case of a raw data which is given. Therefore, this is going to be represented in terms of that specific of course, values of a population given in terms of n, and that's going to be giving us this specific representation. So therefore, we have said that we can obtain the population variance by dividing the square of this, the sum of the square of these deviations by the number or the values, the number of the values of that specific population, whereby this, of course, I represented those specific numbers to an n value, which is a total number of the values of that particular population. And this was a representation of the population variance for raw data. And as we said, we can represent this specific value of population by the frequency distribution by taking account of this specific frequency. And therefore, this gave us a formula representing that specific population variance. In this case, we have decided that basically the values of I are going to represent these values from 1 to a specific number of classes in that frequency distribution. And therefore, this gave us two general representations for raw data and frequency distribution for population variance in that particular case. So take note of this fact that we have squared the deviation for the population variance for both raw data and frequency given as such. Now, the second case, I'm going to look at also the concept of a sample variance, which we have said that basically this can as well be given in terms of raw data, and of course for the frequency distribution, which I've mentioned basically in my last discussion. So for us to obtain the sample variance from the population variance, I mentioned that we're going to less the number of course, those values of the population by 1. And therefore, this gave us a formula of n minus 1, the summation of these specific values of the sum of the deviations from the mean given as such. And of course, we had said that this I is going to represent the values of those number of observations given as such. And this was a representation for our raw data, as I've mentioned. So for our frequency distribution, still we are going to give this variation of the formula, whereby we are going to take note of this specific aspect of frequency and give this formula in that particular case. And the values of I, as I said, are represented all these values ranging from 1 to k, which is the number of classes given as such. Now, from this particular case as well, we can note that for the raw data and the frequency distribution, the variations or the variance are going to be squared. And this has an implication that, of course, as the variations are going to be squared, the units which are going to be encompassing the units of measurement for these specific sets of data as well have been squared. And this is going to pose for us a challenge in a sense that we need to represent these specific units in terms of the original data values. And of course, this is going to request us to find a procedure for restoring our unit. In this case, for a square unit, of course, for us to restore that specific value, we're going to take a square root over that specific representation. And therefore, that's going to give us what we refer to as the standard deviation. So therefore, we can represent the population standard deviation as the square root or the root of this specific population variance now given in terms of that specific symbol, and this implies the square root of this population sample given as such. And as well, we can represent the concept of the sample standard deviation so this is going to be deviation. The sample standard deviation using S, which is the root of of course sample variance given in terms of the square of S given as such. And of course, we're going to see that from our specific illustration, then therefore we can evaluate these particular values for the sample and of course the population standard deviation given as such. So suppose we consider the data which I've given on the right side of the board. And therefore, we are going to use one of the formula which we had derived, of course, from our previous discussion in order to find the variance and the standard deviation of that particular set of data. Now, I'm going to have this specific data represented in terms of this specific representation, whereby this is going to be our observation distribution for that data given as 5. So the first one is 5, and then we are going to have 10, 12, and 17 in an ascending order given as such. So for us, we're going to find the variance, which is going to be that particular observation minus, of course, the mean given as such. And for us to find the population variance or the sample variance, we're going to square our specific values in that case. So for us, we're going to find the first concept. So the steps we're going to take first is to find the mean, which is basically the summation of numbers from 1 to n of the values of xi divided by n given as such. And the total values for this one is going to be, that is 15, 27, plus 17, and that's going to be 44. So the total number of values for this one is going to be 44. And then we shall have this one, of course, divided by the number of observations. So our value for n is equivalent to 1, 2, 3, 4. So therefore, 44 divided by 4 is going to give us the value of 11. So therefore, our mean is represented by 11. So for us to find the specific variance for this one, these are going to be values obtained by finding the difference between xi minus 11. So for the first case, we're going to have 5 minus 11, and that is going to give us 5 minus 11, negative 6. So the absolute value of negative 6 is 6, but we square this value to obtain 36 in that particular case. And that's going to be the same procedure we're going to obtain for the values of the second, the third, and of course the fourth one given in that specific order. So as I've mentioned, of course, the totals for these specific values are going to be 74. We can do an evaluation in order to ascertain whether that is the specific value. So in this case, we're going to use one of the methods we had obtained for raw data in the representation of this specific concept of the standard deviation, whereby we're going to have a sample variance represented in terms of the values of n is equivalent, I is equivalent to 1 to n, and that is going to be the summation of the deviations from the mean given as a square divided by n minus 1 given as such. And this is the specific formula we had given for that particular case. So if we try to look at this second part of our row, is going to form that square deviation, and that's going to be the summation of the square deviation from 1 to 4, whereby we are going to have this one, and therefore, so this is going to be giving us our formula of the summation from I is equivalent to 1 to 4 of the specific variances over xi minus 11 squared all over 3. So this is going to be n is equivalent to 4. So 4 minus, of course, 1 is equivalent to 3. And this is going to give us our general formula for finding this specific representation for the sample deviation given as such. And we're going to obtain this value as 74 divided by 3, which is equivalent to 24.67, giving us our sample variance. Now we have decided that from one of the formula that we can obtain the sample standard deviation using S, which was the root of S squared given as such. So for us to find the sample standard deviation from that particular case, we're going to find the root of 24.67, which is equivalent to 4.97 given as such. And that's how we can obtain the sample standard deviation from this specific set of data. Now, for the case of the sample or the population standard deviation, of course, we're going to follow the same procedure by employing the specific method which are given for the population, and therefore finding the root of that specific representation. So in this case, I assume that we have understood the concept of a standard deviation, which is basically an elimination from the squaring of the units which were used in a particular sample. And of course, we had to look for a procedure of restoring those specific units by taking the square root of that specific value. And that therefore is going to give us the concept of a standard deviation, which we have of course used a specific example to elaborate in this particular case. Now I presume that we have understood. Kindly check our description boxes for various links of other similar videos for us to have a comprehensive aspect of this concept of standard deviation. So that is it for now, guys. Bye, God bless you. Catch us in our next video.